So in this problem, we're using this general exponential growth and decay model. Here, we're talking about a medication. So the half-life of a certain medication in the bloodstream is 32 hours. How long will it take for the drug to decay to 60% of its original dosage? One thing to keep in mind here, 60% of is times, and the original dosage is going to be a sub 0. So when I'm looking at this model here, I'm going to replace A with that 0.6 times A0. Right? We want the amount that's in the bloodstream to be 60% of the original. The amount that we want is 60% of the original. So now I divide both sides by a sub 0. That's going to clean it up, because then these a sub 0's are going to disappear. Now I'm going to be left with 0.6 equals e to the kt. And I'm trying to find how long it'll take. I'm trying to solve for t. The problem is I have two variables here, k and t. So I'm going to need another equation to solve and figure out what k is somehow. What I haven't used is information about the half-life. So if I look at this model again, and I think about the half-life, well, to figure out k if I know the half-life, I want the amount present to be half of what it originally was. So 0.5 a sub 0. And I don't know what k is, but the half-life is 32 hours. So I plug in 32 for t, and now I'm going to try to solve for k. So I'm going to divide both sides by a sub 0. That's going to get rid of a sub 0 on both sides. So that cleans up my equation nicely. We get 0.5 equals e to the 32k. I can take the natural log of both sides. And the reason I'm doing that is because now I can bring the exponent down in front. And the little trick with that, of course, when I have the natural log of e, that really says e to what power is e, and so that whole thing is really just equal to 1. So then I'm just going to solve by dividing by 32. So I'll get natural log of 0.5 divided by 32. On most calculators, I hit the natural log button first. It's going to start a set of parentheses. If not, you might want to start parentheses, 0.5, close parentheses, divided by 32, and then enter. On sum, you have to put in the 0.5 first, and then take the natural log, then divide by 32, and hit equals. We're going to want to carry around lots of digits for this value of k, and so if we do this on the calculator, you should get k is approximately negative 0.0216608. Okay, so what I'm going to do with that now, that value is going to come up to my original model. 0.0216608. I'm going to take the natural log of both sides. Because now I can bring that exponent down in front. And just like we had over there earlier, this natural log of e is just equal to 1. And so to solve for t, I'm going to divide. So it would be natural log of 0.6 all over negative 0.0216608. So on most calculators, we hit the natural log button first. It's probably going to start a set of parentheses. So then I'm going to do 0.6 and close the parentheses, divided by, make sure you use the negative button and not the minus, not the subtract. On other calculators, we have to put in the 0.6 first and then hit natural log. Then I'd put in the 0.0216608 and hit the plus or minus later. Don't forget the equal sign at the end. And if we do this, my t is about 23.58. If I round to the nearest tenth, then we would get t is about 23.6. And notice the unit of time here is hours. So almost a day. Okay, it takes almost a day for it to decay to 60% of its original dosage. This business with half-life and medications is important because usually a particular medication has to have a certain presence in the bloodstream to be effective. And if it drops below that certain percentage, it's not going to be as effective anymore. And maybe a manufacturer has decided, or when they've tested this through the FDA, they've decided it has to stay to at least about 60% of its original dosage to be effective. If it starts to drop below 60%, we need to get it back up to 100%, so the person needs to take another dose. For this drug then, this is about 24 hours. What you'd say for this person, maybe you need to take this drug once per day, once every 24 hours. And of course, you probably noticed with medications you may have had, sometimes it says to take once a day, sometimes twice a day, sometimes 4 times a day. It all depends on this idea of half-life. And that's how those dosage instructions get developed.